Hello guys, very good evening. Let me know in the chat you guys can hear me. Thank you Arad for confirming how you guys are doing. I know we are this time meeting so early. Like I think just 24 hours ago we met, and we are again meeting here. Oh yes, 21 hours. Okay, very specific, huh? I'm also doing good, Ekta. So actually, today, in US, Thanksgiving has started. So today and tomorrow, it would be. It's not much work which I had today. It was just looking into some of the older chats and some of the older things. Nothing specific to work today. So yeah, it was like. Each day I also packed all my bag and everything. So after this class, I'll just continuously just check all the stuff, like, because I'm going to carry this laptop also, and the stuff which we needed for the next two classes. Going to keep it everything in the bag, and tomorrow morning ready to go. Yeah, ready to go. What about you guys? How was your day? Next week I will be there. I will be taking the Monday class. That would be our last class, where we would be solving some of the interesting problem in arrays. And the Saturday class will also be, I will taking it on the same time, morning, 10 o'clock. So I will be available there as well. It's just tomorrow class I won't be taking it. Yeah. Okay, guys. So that's all about here and there. So whatever questions we have practiced in the last class. Oh, you are practicing world class. Well, that's great. I think we are left with one problem. I think let me see that problem first. So that was the short triplet one, right? Correct. There was one problem on the triplet one. So I was thinking like it was not in my slide, but I looked into the question, and that was also not difficult actually. So let's go quickly to understand the logic about it. And by the way, I've already put the like, if you go into the linked list folder, I think you guys can see the code also for that. Yeah, this one, the SRT triplet here. So that's what the code is also available. So I'm going to just explain the logic quickly about that question, and then we can jump into the today's topic. Okay, guys. So quickly, let's talk about the previous one class topic. So yeah, this was the question, right? I've just copied the question here also. So we have been given a linked list, and in this linked list, we are only going to have nodes which are going to have the values between 0, comma 1 and comma 2. So we are only going to have three type of values in a linked list. Okay, 0, comma 1, comma 2. Right, guys? And now our task is we should be sorting this linked list, and after the sweat after the like sorting it out in the increasing order, all the zeroth node will be coming at the head, like the at the head position. Then one will go all the one will go into the middle, and all the two will go into the end side. That's what we need to do it. That's what you can see. The input is like this: 1 comma 2 comma 2 comma 2. Let me draw that input in the one note as well. Quite a lot of OneNote now we have. Let me quickly delete it in meanwhile. Other people can also join it. Let me quickly delete it, because sometimes I feel like might be these I have opened these many these notes. Might be that's why it is hanging. So let me quickly. I can won't take much time, guys. We have deleted all the files. 1 minute. Yeah. So now we have deleted, I think there was more than, I think, 20 files which we had. Okay, I'm expecting my marker should work today. Otherwise, I'm going to change it actually, After the Monday class, I think I'm going to change it for the next module or any other classes, because I think, the nip of it has been, I think, totally washed out or something like that. It happens. Okay, so that's all. So let's go into the question, guys. So what is our question is saying? We have one input like this. Okay, let's choose one, two, and yeah, multiple two are there. Then multiple one are there again. Sorry for that. Yeah, let's draw it again. And then we have some zeros as well. And then at the end we have null. Correct, guys? So this is the question they are saying. You can see zeros are there, one are there, and two is there. And now they are saying that, guys, we need to sort this array in a way all the zeros should come at the first. It's simple meaning of sorting. Why I'm telling you how all the zeros should come in the first. You just need to do simply sorting, and after sorting, all the like by default, after sorting, all the zeros will come at the header positions, like at the starting position, they will start it. Then all the one will come at the middle. Then all the two will come at the end. Correct. I hope everyone understood the question. So see, for this question, output would look like this. This is our input, and our output will look like this. After sorting, all the zero will come at the first. Then you can see all the one. How many ones are there? Four one are there. One comma one comma one comma one, and then remaining twos are there. And they are very specifically they are saying it that in this linked list only we have three digits, 0 comma 1 comma 2. Okay, that's how they have made this question very easy. That's how they made this question very easy. So I hope everyone understood the question now. Anyone has any doubt about the question? Yeah, we are good, right? So let's understand. I think now they have, because they have specifically said that we are going to keep only three digits here. So what we are going to do here, guys, we are going to first traverse this array. We are first going to traverse this array, and we are simply, I've got the video now. Everyone able to see me and hear me? Or is it you guys are having some problems? Ah, okay. So yeah, Joseph, you just need to refresh your browser. Okay. Okay. So yeah, as I was saying, so in this question, guys, because they have said that they are only going to have three digits, which are 0, comma 1, comma 2. So now we just need to traverse our linked list first, and then we will take three I think pointer for that. Yeah, like 0 count, 1 count, and 3 like 2 count, and we'll simply increment those counters. How many times those things are coming, we'll simply increment those things, those three variables. Correct. And after incrementing, we will just start from the 0 counter. We'll add all the 0th element, then we will add all the 1 element, then we will add the remaining 2 elements. That's how we are going to solve this question, guys. So let's see. If we are going to solve this question, so what we'll do, first we'll start traversing this linked list. And we'll take 3.3 variables here. And the variable name look like this: 0 count, 1 count, and 3 count. Sorry, 2 count. Not the 3, because we have only the 2, say 2 here. So it would be 2 count, something like this, yeah. So now let's start traversing this linked list one by one, and let's increment these counters. So first time we have seen 1 here. So what we will do? We will increment the value of 1 here. Correct? The one count value will become 1. Now we'll move our pointer from here to next element, which is 2. So we'll increment 2 count as well. Right? Now again, next element, it's again 2. So we'll add it here. Right? Let's move further. Let's go to the next element. Again, we have seen 2. So we'll increment to 3 here. Now, again, we have seen 1. So now let's increment to this as well. Now, let's increment again, because we have again seen 1. So this will be again, we have one more 1. Now we'll go for this element. Right, guys? And now we'll again increment this to 4. Now we are seeing 0 first time. So here 0 1 will come because we are seeing 0 first time. Now we'll go for this next 0. We'll increment it to 2. So at the end, after traversing whole linked list, guys, these are the values finally which we are going to get it. So and you can see also through the visualization as well. We have we have two zeros here, 4 1, which are these like this, 1 1 1 1, and we have two threes here. Now we just need to simply stay go to the zero count and start adding those elements. First zero would be our head. So like this dot head. We'll start a new linked list, or in the existing linked list, whatever you want to do, guys. In the same linked list, if you want to edit, you can just start from the same linked list. For this dot head, you can take it as a current until you got zero dot count, till you got zero dot count as a zero, till you make zero count variable to zero. Add all the elements here. See, there are how many zero counters there? Two. So 2 times you will add zeros here. Then how many times one is there? 4 times. So you will add one 4 times in the same linked list. Same again. You how many times you have two? You will add those many twos here as well. That's how we are going to do it, guys. So we are simply going to add all the numbers while traversing it. And then after when we have the count of it, we'll simply run a loop and update our existing nodes, update our existing linked nodes. Let me also show you the code for this so it will make more clear to you guys. Okay. So this is simple linked list class. So we'll not go into that. Okay. By the way, because we have written the segregate function inside that, so we have to go into the list class only. I was thinking it would be outside, but no, it's inside. So yeah, let's see that. So this is our values array, which we are going to pass to our segregate method. After that, we simply added all these values into our linked list. You can see these methods for adding it. Then we are simply printing it out. Then we are calling our segregate method. So all the elements are already had been added here. So now if I call if I open the segregate method, so you guys can see. So first we have taken our head into one SP variable, right? Then we have taken 3 pointers here or 3 variables here, which are going to save our 0 count, 1 count, 2 count. And then inside this while loop, we will just, wherever we are seeing the value as 0, increment our 0 count. Wherever we are seeing value as a 1, increment our 1 count. Else increment the 2 count. Why we are not checking for sp.data is equal to 2? Anyone wants to tell me in the chat? Why we are not checking specifically for sp.data is equal to 2? Why we are only checking for 0, 1, and in else part automatically we are incrementing 2 count plus plus? No, that's fine. I'm saying why we are not checking for 2? Yes, other one will be 2 only, because in the question they have clearly mentioned that there will be only 3 digits in your input, 0, 1, 2, and we have already checked 0, we have already checked 1, so by default the last one will be 2. So that's why automatically all the else scenario will be here, and then we are doing sp is equal to sp.next. It means moving to the next node. You know that, right guys? In the linked list, we only can move to the next node through the sp.next when we know the next pointer values. So that's why line number 53 for for moving to the next element. So now when we got all these count, just simply, guys, as I told you, just take the current pointer and add everything in that node, as a, like, they are, say right now they are, I think, directly updating the value of each node. You can see in the current they are simply updating the value of that node, 0, and then current dot next, and then decrementing the value of 0 as well. So this 2 time will be 0 count will be added in our question, because 0 count value was 2. So 0 count will decrement till it becomes 0, and then we will simply add up. See, you can see those current values we are updating, and then we are going for the next value as well. Then same, once all the zeros has been added, now we'll go for 1. Now we are updating the 1 and decrementing the count of 1 count. Same for 2 count. We are updating the value of 2, modifying it and just decrementing it. two count minus one is. You can see later on, guys. You can just fix this code or make it little bit more closer. Like some like right now, you can see a lot of things is here. Like a lot of things looks like common here, right? But still we have written three while functions. So you guys can later like merge this code and combine it and then test it out. But this, yeah, it's just for making this equation easy for you guys. You can see that how like whatever step which I explained outside, those are the things which are happening here as well. I hope now this code will you guys have understood this one. The left over will be 2, right? Yes, yes, Sarad. The left over will be 2. So I will read this code for some minutes so you guys can see it quickly. I will open this one as well. And then we can jump into the next question. So these are all of the count variables. This is the part where we are incrementing the count. This is the part where we are updating our linked list values, node values. Understood, guys? Anyone has any doubt here? Any queries? Hariharan, Suraj, what do you guys think? Joseph, Arad has already said yes. Hariharan has joined this or not? What about you, Joseph? You have joined it. Are you able to hear me now? Oh, yes. Did you, Joseph, you understood the question and the solution? Any queries, Joseph? Okay, that's fine. That's fine. If you have any queries, just let me know right now. If you stuck somewhere, correct? Because if you know this happens sometimes. We are trying to think something, and then it happens that when I'm discussing in my interview, in the Teams call as well. So somebody is explaining something, but I had some thought, or might be I stuck somewhere, so I cannot move forward from that point. So then I again say to the my managers or the team in the team meetings, so for pardon again, or can you repeat it what you said. If that's happening also to you guys, so just let me know wherever you guys is stuck, because that's the point that is stopping you. Yeah, yeah, it happens to everyone actually. It's not with the specific. It happens to everyone. Okay. Okay, guys. So that was the question from last slide, which I think Hariharan has told me, but I'm thinking he has not joined it today, so he can watch this question later. That's fine. So let's look for today's question, guys. Okay. So today's topic is, and let me know if I missed any of the questions, because it looks like you guys have some other questions in slides, but because from the last class, as I can see, you guys have some extra questions, right? But let me know if you again at the end when you guys have some extra questions which is not covered here. Okay, so I will just look into that one and explain in the next class. Okay, so today's guys we are going to discuss about the some of the problems where you will see that we are going to somehow use the sorting techniques. Okay, like those questions will be solved with the help of sorting strategies, or we need to somehow sort the arrays to get the answer quickly. So those are the things we are going to discuss in today's questions, guys. Okay, so before moving that, okay, so in JavaScript, do you guys understand how we do the sorting there? In the JavaScript, if somebody is giving you an array, and if you want to sort it, we already know right, that the JavaScript already provides us very nice sort function, dot sort, and we can simply, yes, the sort function, and we can simply do the sorting there, correct? And sometimes for doing the mathematically, because sort function also provide you one callback function, because in the sorting two types comes, right? Ascending, descending, right? Sometimes we have to do the incremental, sometimes we need to do decremental. So in the sort functions, they provide one callback. So with the help of callback, we decide we need to do the like in the increment order or in the decrement order. right? I think by default it does in the increment order. If you're not providing that callback function, so it automatically does in the increment order. So lower value will come at the first index, and then all the incremented values will be sorted in the order. So that's what I want to say about the sorting. And I think we have discussed a lot of sortings there, guys, right, guys? So one was the iterative based, iterative based, and second was the non-iterative way, right? In the iterative way, I remember we have talked about, we have started talking about the bucket sort, then we move into the selection sort. There was insertion sort as well, right? These were, I think, and you guys can also like tell here. So right now we are talking about the iterative approach where we have to use the iterative. So I think Redux and count comes into the non-iterative way, right? If we talk simply about the iterative ways, so I think bubble sort comes there, selection sort comes there, insertion sort comes there, quick sort come there, merge sort come there, right, guys? These are the five sorts I remember. Any sorting algorithm which I'm forgetting right now? No, no, Suraj. Heap is different. Heap is a data structure, not a sorting algorithm. Yeah, heap is different part, different thing. In heap we do sortings. In heap we do sorting, right? Min heap. So we have to do the minimization sorting. A quick sort already told about, right? Anyone which I'm missing, guys, in the iterative approach? No, right? I think it was the bubble sort, selection, insertion, then quick and much. I think these are the five sorts. We can check it, no problem. We can check in the code as well because we have code, right? So let's check in the sorting folder. So yeah, we have done the selection sort, quick sort, insertion sort, and bucket sort, right, guys? And there was merge sort as well. So these are the sorting algorithm. We have already done it. Binary search, that would come in the searching part, right? Like that will not come in the sorting algorithm part. The searching part would be different, right? And now let's talk about the non-iterative one. So yes, in the non-iterative one, the Redux and count and bucket. I think these were the three, right? Which was the important one, and the bucket was using somehow the Redux version as well. Correct? If you guys remember, I still remember about the bucket sort because that was a new topic which I started. Before that, I think you guys have already covered all the sorting algorithm. I remember. So I think bucket sort. I remember we look for the last element, like if there are like 13, so we look for the 3 in that 13, and then we sort the first digits, then we sort together all the digits, and then based on that, I remember we create some buckets, and then at the end we just when all the buckets are internally sorted, then we take them, print them out in our output. Something like that we were doing in the Redux sort and bucket sort. Okay. Can you tell me one more time what is the iterative and non-iterative sorting? So yes, Nishan. So see, in iterative ways, for sorting our arrays, we were using the mostly for and while loop. We were iterating over all the elements, and we were trying to find, like we were trying to do in place algorithm there. Like we were trying to find out the same, find out the places in the same array, and again we were iterating into that part. If you remember in the bubble sort, we try to find out the bigger one and keep it in the first place. Then we again do the iterative approach, like we again iterate over the remaining element, then we take out the max element, then we put it again there. That was the iterative approach. We are continuously iterating every time to find out the find out to sort our elements. But in the non-iterative approach, you were seeing we were using some extra spaces there, like in the Redux sort or bucket sort. We're trying to do some other strategies rather than finding out our solution with the iterative way. We're trying to find out some other ways, like through the mathematics or through the whatever data has been provided to us. Some we will put some logic on data, and then we will try to find out the sorting things. So that's what about the non-iterative approach. Okay, so that was the difference about these two. And most of the places, guys, we use the iterative approach to find to sort our elements. Okay, for sorting through the Redux and bucket, there are some of the use cases when we have lot of data places and lot of data is stored in our databases, and we want to do it like when we have lot of space as well, we want to do the lot more data. So we'll take some of the data and put it in the memory, use our buckets there. Those were some of the scenarios where we were using the non-iterative approach. But the iterative approach we were using most of the time. So and the questions also comes whenever they will talk about the quick sort and merge sort there. Specifically, they specifically ask about the quick sort and merge sort. Okay, and they also provide, I think, better time complexity as well. Like the merge sort, it provides in all the scenarios. In the all the three scenarios, it provides the same time complexity and login. You can see that there would be one time complexity sheet will be there, which you can use there to understand the time complexity as well. So there are questions like which sort is better, like in MCQ questions, or more questions like that, how to do all that type of questions. So I think yes, in the time complexity, there would be questions which would be asked to you. So you should know the time complexities of all the sorting algorithms. Those type of questions definitely people ask here. Yeah. So Redix sort. So in the Redix sort, I remember Redix sort we use for when we have element between 0 to 1, right, guys? When we have element between 0 to 1, and we were using, I think, after the decimal, whatever elements was coming, I need to check the Redix sort, by the way. But yeah, something was, I remember whatever I can remember right now. It was like we have element between 0 to 1, we can sort it. And again, I think this was again like we have to put the elements in some bucket, something like that. It was there in the Redix sort as well. I didn't remember it correctly right now, but yeah, something like that. It was there. Yeah. They will ask like given array sorted, and will ask which sorted better. So in the interview, I have seen most of the time they will ask you to write or explain the logic about how the quick sort works, how the merge sort work. They will like ask these type of questions, right? And and they will definitely ask time complexity. They are going to ask everywhere. Like I remember in my last interview, there was some question where I need to sort my array to get the answer easily. So then now they are saying which sort algorithm you are going to use it. They just want to understand which sort algorithm which will give us better time complexity with a large input of data. So these type of question they will ask. They generally, I have not get any of the interviews where they are asking me to write quick sort or merge sort. Till now, I have not got it. So they are just simply asking about the logic, what is behind that, and then they are asking about the time complexity. So merge sort, Suraj, it was like that, right? We divide our whole array into two parts, then we divide it again, and then when at the end we got one element, and then we start at the end we just when we have the last element at the last label, then what we do, we just sort them first and then we start merging them, right? That was the merge sort, merge sort logic. Code also. So code, I think it's not in the repo for the merge sort. Yeah, I was not able to see it here. Yeah, I think we do not have the code for merge sort. Sure, I will add it. I will add it. No, no, code didn't ask. No, no, they have not asked me to write the code for that. They just ask like, which sorting algorithm would you think? And see, I still they were they were asking me to use a priority queue actually. See, I will tell you in that question where they asked me about it because I was using the sorting, but the real they want me to use the priority queue there rather than using the sorting because in the because see through the sorting I was trying to find out somehow the minimum element at the top. That's why I was doing the sorting. So I remember that questions. In that question, they want me to use priority queue or heap, min heap or max heap. That's a priority queue only, right? So that was the question actually. So that's why they jump into the question that which sorting algorithm would be better, or why do you think? That's why. Otherwise, if I would be using the priority queue from the starting, then they will not also go to that questions which sorting algorithm there you are using or not, because everyone now they know, like, whoever is right now starting the DS, they have to study the sorting algorithm. So somehow everyone knows about whatever the sorting algorithms, whatever the sorting algorithms complexities are there. So that's why people already like in my level when I was giving interviews, so they already have the feeling that he already knows those things. Might be in the fresher, right? When you guys are giving the interviews, so there might be chances they will be asking you more questions on the sorting algorithm. Yeah. So yeah, that could be the reason. Yeah. So then yeah, it's fine. So just prepare all the seat, time complexity seat of it, and also the logic of it, how these things work. Okay. The priority key means yes, priority key means min and max. Okay, guys. So that's all about the theory part, guys. So let's now jump into our problems and let's start to think about how the sorting is going to help us while solving these problems. Okay, guys. So you guys are able to see my screen, right? It's already saved. Yes. Okay. So now let's jump into the our default sort function is based on which sort. In the JavaScript, it uses, I think, two combined sorting algorithm. It looks like it uses quick sort plus insertion sort. Like they have not clearly mentioned in the JavaScript doc, but yeah, that's what Ekta is also saying. Insertion and two pointer quick sort. Yes, that's right. It uses internally. See, for shorter input, it uses insertion. It looks like, and for the bigger input, when you provide, it uses the quick sorts. That's how somehow they have written in the JavaScript engine for the sorting by default sorting algorithms. Okay, so it uses like this. But there are some documentation which are very theoretically written. If you want to gain more knowledge on that, I would say that you start reading about them. Yeah, but yeah, I think they use the combined, and they use the smart way. For smart input, they go with the insertion sort, and for the bigger input, they go for the quick sort. Yeah. Okay, so let's now jump into the questions, guys, and let's try to solve these questions. I think some questions are interesting there. Some questions are easy, but some questions are also interesting. So let's think about them. Okay. Okay, so now, guys, we have the first question. So in this question, they are saying that we have been given an array of n numbers, and then they have given one more integer as a 3, as a k. And your task is to select k numbers from an array such that the absolute difference between selected k numbers and remaining number is maximum. And you need to print the maximum absolute difference as an output. I know some people might be confused in this question. So now let's go into the OneNote. Now let's go into the OneNote here. And let's open the new page. 18, 4, 15, 12, 10, and k is equal to, this is our array, guys, and k is equal to 3. Okay. In this question, what they're saying, guys, you need to select k element from this array. So right now k value is 3. So we'll say you need to select 3 elements from the here. You need to add those 3 elements. After adding all those 3 elements, whatever output is coming, like after adding k, I'm writing k element. After adding k element, like it will give us sum of 3 elements, right? So after adding this k element, you also need to add remaining element. You also need to add the remaining element. So add remaining element as well. Add remaining element. And then the absolute difference between these k element and the remaining element should be maximum. Absolute difference between sum of 3 minus sum of remaining should be maximum. That's what the output they are saying, guys. So you just need to add any random three elements from here, and then you need to add the remaining element as well. So whatever three element you have chosen, you need to subtract them with the remaining element, and then you need to check is your output is maximum or not. So let's solve it. Let's start to solve it. Solve it. Not means solve it means try to understand this question more with some. Just take some numbers here. So like right now I'm just taking randomly. Let's take 18, 4, and 15. Sum of 3. So sum of 3. So 18, 4 would be 22, and 22 or 15 would be 37. Yes, it would 37. Now let's add the remaining element. Sum of remaining element. So what are the remaining element? I think these two, right? 12 and 10, which would be 22. What would be the difference here? 37 minus 22 would be 15. Correct? So we got the first. This is our first max. Let's try to look for some other numbers here. So let's randomly choose 18, 4, and 10. So here I was taking 18, 4, 15. Here I was taking 12, 10. So now let's take the second sum of 3, which where I'm taking 18, 4, 10. So sum of 3 would be this time 32, right? Now let's take the remaining element. So now, and while taking the remaining elements, let's see what are the remaining elements we have. 15 and 12, right? 15 and 12, so it would be 27, right? So now we can see the difference is 5, which means this difference is still good. Correct, guys? This difference is still good. 15, 1 is still good. Correct? So we need to check a little bit. We will check all the possibilities. We will check all the possibilities. Let's check some other possibilities as well. So now this time, let's take 15, 12, 10. Let's take 15, 12, 10. Let's see. We might get some good answer. So this time, the sum would be again 37, I think. Yes, 5 to 7, 1, 1, 3. Yeah. So again, we'll get the sum of 3 as a 37. And now remaining element. What are the remaining element here? 4 and which one? 18. 4, 18. So it would be 22. It would be 22. So now you can see the difference here, guys. It would be 15. I think, yeah, this is giving us the same difference, right? Which is like this. So 15 is still greater. 15 is still greater. Let's take this time, guys. 18, 15, 12. Correct? 18, 15, 12. Let's take all three greater element here. So let's see what will be the output here. 5 to 7, 7, 8, 15, 1, 2, 3, and 4. Am I adding correctly, guys? Yes, 45. This is sum of 3. Now let's add the remaining element. So what are the remaining element, guys, here? 4, 10, which will give us 14. Let's subtract it. So it will give us 31. Now this is greater than 15, guys. Now this is greater than 15. And now, guys, just try it all other scenarios just in your mind. And I'm saying you, this is going to be your greater answer. This is going to be your answer. And just that's what you can see in the UI as well. We can see in the UI also, sorry, in the slide also, 31 is our answer. We have to take any three elements. Yes, any k elements. And here k is 3. So any three elements you can take from the array. And after that, whatever remaining element are there, you just need to subtract 3 elements and remaining element. And you need to find out the maximum difference here, maximum absolute difference here. Everyone understood the question now, guys? Anyone has any doubt in the questions? Anyone wants me to repeat it? The same thing which we are doing in the previous one. In the last one, I have chosen these three elements, 18, 15, 12. And I found the difference as 31 this time. The three element and the remaining element. So I'm saying that you guys can think about some other scenarios. I'm just giving you some time. Let's take some other three scenarios here. I'm just saying this is going to be our answer. But meanwhile, you guys can try it. Some other scenarios if you want. Yeah. So now I hope you guys have understood this question. Will it work if we take first case smallest element and remaining element will be large, so the difference will be more? Hmm. Yes, Likhit is thinking in some way, and that's right. That's what. Yes, Likhit, you are thinking in correct way. That's right. That's right. Definitely, this will give you. Definitely, it will give you the large difference. But only the smallest element will give you, or think about a little bit more about it. But yes, this one is going to one of the answer. Okay, Sasson is saying that sort array in descending and add them until k. Sort array in descending. Okay. Okay. And add them until k. You mean Sasson from the starting or the in like or from the starting till k, right? Like all the great. When you say descending, it means all the maximum element will be on the starting index, right? Yes, 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 yes. Yes, 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 yes. Navneet. Okay. Yes, Navneet and Sashan is saying totally same. In question, K value not defined. In question, K value is not defined. What is here? It's here, right? Suresh? It was there. When we suddenly, why we need to sort if we need random elements? Yes, Ara, that's what you think. In our PDF is not there. Okay. I might have added it. I might have added it. Yeah. Why need to sort if we need a yes? Think about Arad. Why we need to do sorting? Because think about you need the differences. You need the you need your difference between 3k element and the remaining element as maximum. And when it will be maximum? What are the chances when your maximum is going when your difference is going to be maximum? And you can see in this question, when you have added all the greatest element, when you will add all the greatest element at one side, and you and the remaining element at one side. See, if we sort this array, just sort this array, guys, you will automatically starting seeing the answer. If we sort this array 4, comma 10, comma 12, comma 15, comma 18. So now all the greatest element will be at this side, all the smallest element on this side. So now we just need to, based on our k value, we just need to decide from which side we need to take the out, from which side we need to take the input here. Because sometime, see, Arad, first thing, you need your difference maximum. You need your difference maximum. And how the difference will be maximum? How the difference will be maximum? See, now when we say difference, there are two entities, right? We are subtracting A and B, and we want to make this A and B one of. See, if I take 8 and it has a 5, the difference would be 3, right? A is 8 and B is 5. Now, if I want to increase this one, if I want to increase this maximum in difference, I need to increase the A here, right? I need to increase the A here. So let's see. I need to increase the A here. So it will be become 9, 5. You can see automatically difference is increasing. 10, 6, 10, 5, and 5. So that's what you need, one side all the maximum value. You need one side all the maximum value. Correct? Arad, did you understood now why we are sorting it out? Because sorting is definitely going to give us some answer. Okay. Okay. So now you guys have understood. Definitely the maximum is going to contribute in the answer. Correct. So now just think one more thing, guys. Is it only the maximum is going to contribute in the answer? Now that's the question. For that, you need to understand this same question, when the k value is 2. Let me show you now. Same question, 18, 4, 15, 12, 10, and k is equal to 2. Now this time, with a k value 2, let's try to solve this. With k is equal to 3, we have understood that the maximum, if we take the maximum out of our array, that is going to give us the answer. Correct, guys? First we understood if we take the maximum out of our array. Yes. Now let's take the k is equal to 2. Now let's take the k is equal to 2. Is it going to be same case every time or not? Let's think about it. So now let's see. Now randomly I'm taking, again I'm just starting with the maximum value. Let's see is they are going to give answer or not. So I'm again taking 18, 15 because these are the maximum. We need to select two elements this time. So this is going to be 33. Let's see. And the remaining element. Let's see remaining element this time. So 4 and 12 would be 16 and 10 would be 26. Right, guys? Sum of remaining element, which would be 4, 12, and 10. Correct? So now you can see 26. So what is the difference here? 7. Right? Which would be 7. Let's take some other elements. This time, let's take 15, 12. Let's see if this can give us the answer. So the remaining element would be 18, 4, 10. So 15, 12 would be 27. 27, 18, 4 would be 22 and 32. Right? So they are talking about the absolute difference, guys. So it will be minus 5, it will become 5 because they are talking about the absolute difference. Absolute means minus will also become plus. So this would be 5, right? Still, this one is greater. This one is still greater. Let's take some other elements, guys. Let's take this time 4, 12 as our element. Sum of 2, and here we take the remaining element. So it would be 16, and here would be the 18, 12, 18, 10, and 15. 18, 10, and 15, yes. So 18, 15 would be 33, and this would be 43. Again, let's take the absolute difference, guys. So 7 and 27. So 27 is answer. Guys, this one is greater now. You can see greater than this. This one is greater. Now let's take one more. 4, 10. And this side, the remaining one. 18, 15, 12. This would be 14. 45. Now guys, you can see same 31 again. Again, you can see this one is greater. But this time you have not taken the greater element. This time you have taken the smallest element. Correct, guys? You can see this time you have taken the smallest element, 4, 10. So that's why, guys, in this question, you are going to take first k smallest element. First k smallest element. You also going to check for first last k greater element. And then you need to check which one is maximum. Then it is going to solve all the scenarios of k. You have to take the first k smallest element also as well. You have to take the last k greater element as well. And then you need to check between those two which one is greater. And then it is going to give you the answer for the questions, for all the scenarios. Because see, once you taken the smallest element, once you have taken the smallest element, so all the remaining element, whatever the remaining element would be greater. Now this all will be greater. If there are 9 or 10 elements and you need to select 3 elements from here, which are the smallest one, so definitely these remaining 10 elements would give you the bigger value here, and then there would be difference there. Then there would be difference, right? So that's why you are going to check 3 k smallest element as well, k greater element as well, and whatever the element in the middle, whatever elements are coming into the middle, if you select them or not select them, they will be always be between these two. The answer for the middle elements will always be between these two. That's why the sorting is going to help us. Okay, now let's see. There is no case where we have to take k middle elements. Yeah, there will not be. There will not be, because you are already checking when you are taking the smallest element, you have already considered all the remaining element, there. You have already considered all the remaining elements. When you are taking the maximum element, you have already covered the left side scenario. Guys, in the same question like this, just increase some values, 18, 4, like let's just sort it. First sort it. Where was the sorted area? Yeah, this one. So when you are let's increase this value also. 4, 10, 12, 15, 18, 19, 21, right? And k value is 3. So guys, when you are calculating these three, the last greater, when you're selecting them as a 3, so you have automatically concluded the all these elements, right? You have already automatically calculated the answer for them while selecting these three elements, because you will automatically check these two, which one is greater here, right? And then you are checking for these three as well. For the same question, you're also going to check for these three. So automatically these middle element again got covered. So now you just need to find out the maximum between this one and this one. And whatever the maximum would be, that would be your answer. The middle element will not make any sense now. Everyone got it? That was the interesting question. You can see how the sorting is going to help us here. Correct, guys? Because see, they have given us random array, but if we will sort this array, we are seeing some pattern there. We are seeing some pattern there. If we add the last k greater element and find out the difference of remaining element and last three greater element, that would give us one number. Then first k smallest element, find out the difference with them, then find out which one is maximum, and that one is going to give us answer. Let me show you the code also. Code is also similar way. Whatever we are talking about, code is also similar. I'm just showing you again and again all of my tickets. Let me just put them off. Yeah. So let's see the height difference question. Yeah, weight difference. Yeah. This was the question, right? Yeah, same question. So see, guys, the first thing, we are sorting our array. Whatever array is given to us, you can see in the max difference, they are passing an array, they are passing the value of k, they are passing the n as well. So here you can see, first I sorted my array. This is sorting part. Then I have taken three variables here: sum smallest, and sum largest. Why we have taken the sum? Because finding out the remaining value. Because you know what we are doing here in the slide, you can see we are subtracting, right? We are subtracting. How we are getting this remaining value? There are two ways to get the remaining value. Just add all the elements in this array like this: 18, 22, 37, 49, and 59. So total sum is, I think, 59. Just add it, guys. 8, 4. Let me add it one more time. 22, 5, 27, 37, 39, 49, 59. Yes, this 59. So how to get this remaining element? So 59 minus 37 will give you the remaining elements, because you have selected these three elements: 18, this one, 18, 4, 15. So you are just subtracting this value from the whole sum. So automatically you will get the sum, this remaining value. That's why you are calculating the sum here. Everyone can understood why we are calculating the sum? For getting the remaining values. Everyone can understood why we are calculating the sum values here? Guys, are you able to catch it? Why we are calculating the sum values here? Just to get the remaining values sum. Because you know, we need to subtract what? Do two things, right? The selected three elements, then the remaining part. How to get remaining part every time? So for that, what we'll do? Sum minus selected item. Sum minus selected item. Total sum minus selected item. Not getting, guys? I can give you one example. Just tell me in the chat, guys. Otherwise, how can I understand you're getting it or not? Are you guys getting it? Why we are using the sum there? What about others? Hariharan. See, guys, these questions are now starting a little bit interesting question, right? So we have to think a little bit extra, right? These questions are not tough, guys. Just little bit logic there. Okay, so I'm hoping like everyone has understood why we are doing the sum there, just to get the remaining values. Okay. So now, after calculating the sum, what I told you, I will calculate smallest k element. So you can see my loop, I is equal to 0 till k. So in the sorted array, I just calculated the sum of smallest. Then I told you I will calculate the sum largest from the last side, from the back side. So you can see the loop for that as well. I'm starting my loop from the back side, n minus 1. N is length here. You can see n is the length of array. So I'm starting from back side, and then you can check here. I'm just going till n minus k minus 1, means last three element. Only run my loop till the last three element. Why I'm saying 3 here? Because I'm considering k as a 3. That's why I'm saying last three element. Whatever k value is, last k elements, you need to traverse it. And we will simply add sum them. And then at the end, what we are doing, I told you. First, I am calculating the remaining. You can see sum minus sum smallest will give us the remaining values. Then sum smallest minus remaining value, sum largest minus remaining value. Then calculate the absolute values of them. Then find out which one is max. Which one is max here. That's what the question is, guys. Let's see why we are doing sum minus sum smallest for fetching out the remaining values after selected k smallest element. Whatever the remaining values are here, after selecting the k largest element, whatever the remaining values are here. That's why we are doing sum minus sum largest, sum minus sum smallest. And then we are, as I told you, this will cover all the scenarios here. Which one is maximum between those two? Just take them as the answer. I hope you have understood that. So repeat example for array more than 7 element for k is equal to 3. Amlet, can you explain the question again? So Deepak, question was this. We have been given one array, right? And then we have given one value k as a 3, right? And then what they are asking to us, you need to select those k elements from your array, and whatever the remaining element are there, you just add those three elements, those k elements, you just add those k elements, and then in that array, whatever the remaining elements, you just add them as well. Then find out the difference between them. The k element, sum of k element, and sum of the remaining element. Whatever the difference is there, it should be maximum. And you can select any k element from the array. That was the question, okay? Understood question? Deepak, have you understood the question now? Yeah. So that was the question. So so let's Joseph wants to understand with the 7 as well. So let's take in the same array. This is the 5 elements, right? So 18, 4, 15, 12, or I think, yeah, this one's 7, right? 1, 2, 3, 4, 5, 6, 7. Yeah. So just take the same one, right? So Joseph, what we will do here, according to code, we'll first take the sum of whole array. Take the sum of whole array. So just add it. 14, 26, 41, 59, and 78. Yes, 78. Then 99. Yes, 99. So the sum would be 99 here. Just add it one more time, guys. So 14, 16, 10, 26, 31, 41, 49, 59, 59, 68, 68, yeah, 68. This would be 78 then. 78 and 79 and 99. Yeah, sum is 90. So first, Joseph, we will calculate the sum of this. Now, sum of k smallest element. K smallest element. So we are considering k as a 3. So these would be 3 elements for them. So 4, 10, 12. So sum would be 26 here, right? Then we are finding out the sum of 3 greatest element. Sum of k greatest element. So sum would be here 37, 38, and 58. Sum would be 58 here, right, guys? 58. Now what we are doing, guys, same thing. We have to find out the sum minus remaining. So these are the three smallest element, right? Now we need to find the remaining element as well. So for that, what we'll do, 26, this is my sum smallest, this is my sum smallest, then remaining element, right? These all remaining elements. So for remaining element, what I'm doing, sum minus sum smallest. Total sum, this is total sum. Total sum minus sum smallest. So 26 minus total sum is 99. minus sum smallest is 26. So 26 minus, this would be 73. Yeah, yeah, 73. Yeah, it would be 73. Then the difference would be here 7 and 47. Right, guys? So difference would be, when we are considering sum as small as, we are getting difference as a 47 here. Let's now go for this one. Let's check here. So 58 minus 99 minus 58. This will give us the remaining element, right? 99 minus 58, it will give us these remaining elements. So 58 minus, find out 41, right? This will give us 41. Yeah. And now you can see this will give us 17, right? This will give us 17. You can see this one is the greatest. So you will select these three elements, 4, 10, 12, and this will give you 47 as the greatest answer. Now you understood, Joseph? Oh yes, we are taking first three elements and remaining. Yeah, that's what we talked about. Okay, so Navneet is saying if k is less than size by 2. K is less than size by 2. Okay. Okay. Then we take smallest kth element, and if k is greater than size by 2, then we take larger k. I think we can try this as well. Size means array dot size. Okay. This k is less than size by 2. So right now it's a 7 by 2, which would be 3, right? Like in this case, 7 by 2 would be 3, and k is less than size by 2. So k is not less than here because both have 3, 3. We take the smallest k element, okay? And if k is greater than size by 2, then we take the larger kth element. I think we can try this as well. So in the case of fifth 5 and divided by 2, so it would be 2 and k is greater than 3. Yeah, makes sense. Makes sense. But yeah, I think this one is also right, because this one is going to consider all the scenarios. You do not need to check for size or anything there. You just need to find out the first smallest element and the last, because this is going to be generic solution for all the scenarios. And then you just need to find out the maximum between those two. That would be your answer. Right, Navneet? Deck solution is easy path as well. Deck solution. You mean the same solution which is written there in the slides? Yeah, that's the same solution I have explained. Same solution is there. Same solution I have explained to you as well. Yeah. So I hope everyone has understood now with this example as well. Suraj, Arad says yes. Joseph, Ekta, Likit, Vishal. Vishal has joined class today. I'm not seeing Vishal responses here today. Ankit, I have seen Ankit is there. Ankit has joined the class today. Let's see who else has joined. Navneet, okay. Session. What about you, Session? Only these people are only responding. Session, are you still there? And sorry if I'm just like pronouncing your name wrong. Sorry for that, guys. Oh yeah, 19 are there, but only 6 and 7 people are only responding. That's strange. Okay, now let's jump into the next question. Yeah, actually, every time it feels like to me that only 4, 5 or 6 people are only responding. I'm not sure why all people are not responding. It's weird, right? Okay, now let's jump into the next question, guys. Yeah. Okay, yeah, this question is also interesting. Sorting nearly sorted array. Sorting nearly sorted array. Yeah. So see, guys, see, they have given very nice, very easy solution. They have just simply given the insertion sort. But I will tell you one more solution for that, which would make some sense. So see, what is the meaning of nearly sorted array? So guys, they have been given you one array. like this: 19, 18, 17, 14, 17. You can see this input. They have given you was one array, and then they have given you value of k, right? So now what they are saying, each element in this array is at maximum k distance from its actual position, from its actual position. And your task is to sort this kind of array with minimum time. Your task is to sort this kind of array with minimum time. So see guys, what is the meaning here? Let's just take the same example, but it's an interesting question actually. 19, 18, 17, what else? 14, 70, 60, and 50. And the value of k is 3. So what they're saying, guys, each element in this array would be at at most distance k from its actual position. It means for this 19, the actual position for this 19 would be at the 3 distance not exact the 3 difference between between these 3 distance from the right side or might be on the left side. But yeah, the at most difference or the max distance could be 3. This 19 cannot be put after this distance. That's what they're, and after sorting, just if we sort this array, you will see 14, 17, 18, 19, 70, 50, 60, and 70. You can see, guys, now 19 is at this is the 19 actual position after sorting. You can see it's only inside the three distance. You can check for any element. Let's look for 17. And guys, both sides. It's not only from one side. You have to check for both sides. You can see for 17, it has one position. And I told you max 3. Max 3. I'm not saying that exact 3. I'm saying max 3. It could be one distance. It could be 0. It could be like it's already at the right position. It could be at that. It could be at the 2 distance, or it might be at the. But yeah, the question is here. It cannot be more than 3 for any element. The actual position cannot be more than 3. That's what they are saying. That's what the information they have given to us. And then they are simply asking us to sort our array. I hope everyone has understood the question. Then they are saying us to sort the array. So Joseph says no. So Joseph, in this is our input. You see, this is our input. And they're saying this is 19. They're saying after sorting 19's actual position or the place for 19 would be only at the k distance, not more than k distance. So right now kth value is 3. So it means 19 can be put after the 3 elements, or the max distance from this position for 19 to be after sorting, this would be at the max 3 distance. So that's what you can see. 19 is coming at the 3 distance. This is our output. After sorting this whole array, this looks like this. 19 could be at this position. 70, just look for 70. 17 could only be 3 distance this side, 3 distance this side. But you can see after sorting, 70 is coming at this position, which is, you can see from the original position, it just how much distance he has moved, 1 and 2. That's why you can see 70 at this distance. Same for any element, just take it. Take the 60, you can see 60 at the same position, right? 50, you can see for 50 is moving 2 distance this side, 1 and 2. That's what the question is here. Okay, so they have, see, the question is nothing here. Question is just sort the array. Question is just sort the array, but they have given you some information. So they are saying that you should use this information and reduce your time complexity here. Reduce your time complexity here. Almost at most 3 positions it moves. Yes, at most 3 positions. K is given. Yes, K is given. K is given. Yes, at most 3 positions it can move. No, it can move, or no, it moves almost 3. Yeah, almost 3 position it moves. Yes. In any direction. It could move to the left side as well. It could move to the right side as well. Any direction. And they are giving you this information, extra information. But at the end, you need to sort the array. And after sorting the array, you can only find out how much distance it has covered. Now everyone has understood the question. At the end, you have to sort this in array. But they're saying, can you use this information and reduce the time complexity here? Guys, understood? We have to find distance here. We have to sort the array. That's what. We have to sort the array, Joseph. We have to sort the array. But they're saying, can we use this information which they provided us, that the any element which after sorting, that will only be at the 3 distance or k distance. They're saying, can you use this information and make your solution more like time complexity or less time complexity, or more like efficient, more efficient. That's what they're saying. You have to sort the array. That's why if you see the slide solution, if you see the slide solution, they're using the insertion sort only for sorting the array. You can see that, you can read that one also, the description as well. We can think of some different sorting algorithm which can be used to sort it. Iterate from 1 to n. If you will read the code also, they're using the insert sorting here. Nothing, they're not using k anywhere. You can see in their logic, they're not using k as well. Anywhere they're not using k. So the question is very simple. You just need to sort the array. Yes, like if you want to do that's what actually insert sort does, right? That's what the insert sort does. If you guys remember, like what insert sort does, it just start from the starting position, go for some distance, like from 0 to 1, it go there, and then start inserting at the correct position. That's why I take them. I think in similar, this question could be, that's why I think that's what the reason they are using the insert sort there. That's why they are using the insert sort there. But you can see, this is the question. So 19, 18, 17, 14, 70, 60, 50. Correct? So guys, what we need to do? We know that 19 could only be between these 3 positions. 19 could only be between these 3 positions. Correct? So what we'll do, according to loop, what we'll do? We'll first run one loop, which will run I to n, from 0 to n for each element. Then from here, we will go for, we will run one inner loop till 3 distance, and then we will check the element here, because the 19 can only be in these 3 positions, not in whole array. Correct? In the insertion sort or in other sort, what we do? We check each element in the array, right? See, in the sorting algorithm, what we do in the iterative algorithm, mostly we check for 19 should be lesser than all the elements in this array. Correct? 19 should be lesser than all the, like it should be lesser than all the elements, right? That's why in all the sorting algorithm, we got the complexity as n square. We got the complexity as n square. Correct? But we can use this k. We can use this k and reduce our complexity. So guys, you guys tell me, if I want to find out between this k distance, if I want to find out the minimum element, what data structure is coming in your mind? What data structure it is coming in your mind when I want to find out? Because see, in the k distance, I just need to find out the minimum element. That element will come at the first position, right? That element will come in the first position. Yes, it's a min heap. You know that, right? In the min heap, guys, it is coming into your mind as well, the min heap scenario. Yes. So see, guys, in the min heap, it is totally sure that we are not going to move, because see, here it could be n square, the nk, and k can become easily n, right? K can easily become n here, because they are not using k here. If I show you the solution, I've written the solution here. This is the solution without heap. Okay, this one is fine. This one is different thing. This one is different thing. This is different thing. So yes, in your mind, in your mind, yeah, automatically that heap is coming, right? The min heap. But yeah, as I was saying, if you are not using the min heap here, the sign complexity for solving these problems with our own sorting algorithms is going to be n square or n log n. If we are going to use the merge sort or those sorts, right, guys? N log n. That would be the complexity. Correct, guys? Yes. But if we will use the min heap or the priority queue, we can definitely make our solution to n log k. And we can use this chance. We can use this chance to run for the n log k solution as well. So what we'll do, guys? First, we'll add k plus one element in our min heap. First, k plus one element in our min heap. Then we'll start. Then we will start our. Then we will start removing the pulling out the minimum element and putting them in the arith index. Putting them at the arith index. Now I think you guys are able to understand, right? Once we add the one time, we'll add only k element. And how much time complexity min heap take while we add any element in the in our min heap? How much time complexity it takes? Or while removing or inserting, how much time complexity it take? Definitely it takes log k only, right? Whatever element we have added, whatever element we have added in the heap, that much complexity, right? And we are going to only add k element in the k element in the min heap. So that's why it is going to take log k time complexity, and there would be n for iterating our arrays. So that's why with the min heap, the time complexity is damn sure it is going to be n log k, not n square or n log n. It's not going to be n square or n log n. But with the help of min heap, definitely it is going to be n log k. Did you guys understood the reasoning behind this? Why it is going to be n log k? Because in the min heap, it takes log k complexity to give us the min element or remove the min element from the min heap. It only takes the log k. Understood, guys? Understood the reasoning behind this? They have not given that in the slide. I'm just telling you this just extra about it. Okay, now let me show you the code for that, guys. First, I will show you the min heap. Yes, so for an element, it's n log k. Yes, the time complexity is going to be n log k. So first, I'm going to show you the code with min heap when we have the min heap class. Then I will show you one more way. If you do not have a min heap class, how mostly people do that? How they create the priority queue or min heap? I will show you the both ways. So that's why you can see I have created two files here, one with without heap and with heap. And why I'm doing that? Because you guys should know that if you do not have heap class, how will you use the heap functionalities? How will you use the heap functionalities? So what is the heap functionalities? First tell me what is the heap functionalities. Then only we will jump into the code. What is the heap functionalities, guys? Quickly tell me. What is the heap functionalities, guys? Min or max? Any heap functionalities? What happened there? Remove min max from front. Okay, that's the advantage of it. That's the advantage which min max provides us. We poll. Yes, heapify automatically. But what happened in heapify? What happened in heapify? What's the purpose of doing heapify? That's what I want to know here. What's the purpose of heapify there? Why we are doing heapify there? Yes, that's the point. Root element always become min or max. That's the reason. That's the reason we are doing the, that's the reason we are doing. See, in the array, if there are 4 elements added, so always the root element should be min or max. If we are removing that element, the next element from the array should become the min and max. So automatically sorting is happening there. Always the first element will be smallest or the max element. Automatically sorting is happening there. Am I right, guys? Am I right, guys? Yes? Okay, now we have covered the heapify. Now let's jump into the code. I will show you both ways. So first I will show you with heap, where you can see my class heap here, which have the constructor, comparator, swap method, bottom up, top bottom, size, peak, add, contains, every method. Every method we have. Poll, remove will also be there, remove, like the last heap class, which we have created. You remember in the last heap class, we created the remove method as well. I have taken that heap class. Correct? So we have taken that one. Now let's look into our solution. So first I will pass my min comparator, because we are going to calculate we are going to make the min heap, and you can see a less than b. So means if parent index is greater, because we always in the b we always find out pass the parent index. So if parent index is greater, just simply swap the values. Just simply swap the values, because it's a min. So if parent index is greater and current element is smaller, swap the values. That's why it is min comparator. After that, you can see I'm just adding k plus 1 element in priority queue, because for 19 the next 3 element could be there. So that's why I'm simply adding all the 3 elements, all the k plus 1 element in the priority queue. So first I added them. Priority queue min heap, same thing, guys. That's why I'm writing it as priority queue. We have added the 3 elements here. Then I've taken one generic index there, which is going to start from the 0, and I'm going to update my original array. I'm going to update my original array indexes. So you can see first I am taking the peak element. So in the starting 4 element, first we'll add 19, 18, 17, 14. So they will look like this: 14, 17, 18, 19, right? So first 14 will come out from the heap. So that's what. So we'll add it into our index 0, 0. So you can see index 0, it will be added. Then index will be incremented to 1. Then we are first we're taking the peak element, then we are removing it, adding the next element where our I is, and which is starting from k plus 1, because we have already added the k plus 1 element. So now the next element we will add it from here, the k plus 1 element. Correct, guys? Now we are simply adding it, removing the peak from the priority queue and polling it out. Now once this loop is completed, if the priority queue size is still not 0, it means there are more elements. Then simply take the peak element from there and add it into the array. Do the polling every time. Do the polling, add it into the existing array. That's what the code here, guys. Simply take out the element from the min heap or priority queue, add it into your array index. I will wait for some minute so you guys can see this code. Only this much line is there. And let me know if you guys are stuck anywhere. First, I added the k element here. You can see from 0 till k plus 1, it means less than k plus 1. So that's why I added the k element here. You can see 0 to k element. Then we added the k plus 1 to n element, like the remaining element from the queue, from the array. And then after that, once the element has been added, we are simply, because you can see this one is going to tell you that the log k complexity should be there. Log k complexity should be there. You're not going to traverse inner loop n time. You just simply going to take the element from the priority queue and put it in index. Okay, guys. I hope everyone understood. Anyone has any doubt in any line? Let me know right now. I can explain it again. And index plus plus, that is also clear, right? So index plus plus, what it does, first take the index value, whatever current value is index, assign the values there, then increment it. then increment it. So why we are adding the first k plus one elements only? Why not all n elements at? If you will add all n elements at once, then the complexity will become log n, not log k, because the adding elements in the min heap, the complexity is log n, whatever how many elements you are adding, that much complexity. So log k. If you will add all the elements at once, then the complexity will become log n. That's why we are adding this just the remaining the k element at the one time. Understood? So the code once again. Okay, sure. Let me show you the Arad. Index plus plus. This is also not tough. So what an index plus plus does? First, it will assign value at array of 0. Whatever value is coming from the peak, like 14, then it will increment the index value to 1. That's what index plus plus does. If anyone has any confusion about what index plus plus is doing there. This one you're already aware of, taking the peak element, then removing that element, then adding the next element from the array. So this one is fine. Once this loop is ending, there is still some element in the priority queue. Take the peak element. Again, whatever index we have added till now. That's why you can see we have taken separate index here, because the same index till now, whatever index we have incremented, we are going to increment to the next index from there. Because see, inside this loop, we might have added 5 elements into the existing array, but there are still 3 elements, so we have to add in the 6th index. That's why we have taken index out of our loop and again adding it here. For adding, take it from the peak element from the queue, delete it. I hope you guys have understood this one. Anyone? Arad, I understood the code. What about others? Joseph, Navneet, Likhit, Deepak, Hariharan. Somebody has a doubt here? Ekta is out. Okay. Yeah, Ekta. Can you hear me, Ekta?
Means I can hear you. Sure, I had
Okay.
this doubt. Like initially, we are adding the first k plus. So can you show the code?
Sure. Mm-hmm.
So first, on line number 110 and 111, we are adding the first k plus one elements, and we have a
Correct.
guarantee that while we are polling, at a time only the minimum element would come, so that we are adding to our array on line number 116. So like,
Correct.
what if we have something like, let's say, just the smallest element is at the end, or is it like using the fact that all the elements are max to max k distance apart from this from their original index?
Yes, maximum k distance only. That's what the assumption here.
Okay, so that is the. So I got confused, between the like the explanation, the question description and this code. Like, what if we have some, the minimum element at the end, or out of this k plus one range? So it's just using the fact that the elements are at a max k
K
distance
plus.
from its original index.
Correct. Correct.
That is right, sir. Just wanted to
That's
make
right.
sure.
That's totally right. That
Yeah,
was the
yeah.
question actually. That's
Okay,
totally right.
okay.
The element
N-
would be
n-
only at the k distance. You can see?
yes, yes, yes. Then that is also like it's easy only.
Yeah. Then that's
Yeah.
why actually you can see it's clearly mentioned that the each element in the array is at maximum k distance from its actual position.
Hmm.
Okay.
Okay, sir.
Yeah.
Okay, thank you.
Thank you. Coming back to here. Okay. Understood, everyone? What about others? Yeah. Okay. Now, guys, let me show you. If you do not have a heap class, and somebody is telling you have to implement the priority queue. So right now, how we do in the JavaScript? Because in JavaScript we do not have a heap class. Uh, can you guys hear me? Everyone? Oh, let me refresh it. 1 minute. What about now? Is it still same? Might be, might be, somewhere this internet signal aliens has hacked it in the satellite. Might be. Yes, that's what I was thinking. Might be somewhere in the satellite, alien is also hearing it. Yes. Okay, that was all fun part. Okay. Yeah, we'll go for the break. Let's just see one more thing. In the JavaScript, if we do not have the heap class, because we do not have heap class, right, in JavaScript, we have to implement like that, which we did. So, how can we do in the JavaScript? How can we create the priority queue in JavaScript with the arrays? So let me show you quickly that as well. Without heap, you can read the file name as well. I've written wo, means without heap. You can see there we take a small array, we push in the same way, but after the push, we simply do the sorting directly. We simply do the sorting of those elements. That's what how we create the heap. You can see every time we are pushing a new element, every time we are sorting it. Every time we are pushing a new element, every time we are sorting it. And for deleting an element, we use the shift here. That's how we use the priority queue in JavaScript when we do not have a heap class or priority queue class, whatever you want to say. That's how every time we do the sorting, which is bad actually. JavaScript should do something. They should by default provide some heap to us. Otherwise, we need to do all these things to do the logic here. Otherwise, we should know the logic of heap class like this, the top, bottom, and all those functions we should know. JavaScript do something. I'm not sure. I have to read why they are not creating a heap class. But you can understand. That's what we need to do. A minus B means A less than B, ascending. Yes, A less than B. Minus B. A minus B, it means you're doing the ascending. Yes, yes, yes. If you'll do B minus A, if you'll do B minus A, that function will sort the element in descending order. Understood, Ekta? So everyone understood this priority queue part as well. In JavaScript, we do not have a heap class. You can see we are doing sorting, but we are using the sorting method only. So some people might be confusing. We are doing the sorting and we are using sorting method only. You can see, right? We are doing the sorting, but we are doing the sorting all inside it. So some people might ask, what is this? So this is how the priority queue works in JavaScript. That's why I will read about it. I will read about it why they do not have a heap, because it's a like important data structure. See, a lot of problems people are solving with the priority queue. Not sure why they are not providing it. Very sad, yeah. Okay, now let's go for a break. Right now it's 9:50. No, no, no. How can it's nothing like you know what do you say? It's like what do you say? Like it's not like a street fight or something vegetables like that. Globally, people are using JavaScript. How can they forget it? They have some definitely reason for it. Not sure. Yeah, so right now it's 9:32, guys. So let's come back at 9:47. Okay, then we will see the remaining question as well. Is everyone back now, guys? Is everyone back now? What about others? Thank you, Joseph, for confirming. Navneet is also back. I will wait for 1 more minute. Otherwise, people might be thinking it should be 9:47. Then yeah, I will be back. Then we can jump into the next question. Maximum height pyramid. In meanwhile, I can delete some OneNote. So we can. So my marker should not work slow. It looks like they have started working slow. Okay. Now I think everyone will be back, right? It's 9:47. Yes. Okay. Now let's look into the next question, guys, which is maximum height pyramid. Okay. So they have given us one numbers, array of n numbers, where each element represents a width, and we need to arrange them in a pyramid. We need to follow below two rules. And the rules are: width of any ith row in the pyramid must be less than I plus 1th row. Okay. The second rule is total elements in the ith row in a pyramid must be less than I plus 1 row. And after following these rules, we need to create a pyramid, and we need to give us the answer what is the maximum height we can achieve after applying these two rules. Okay, before that, let's draw how the pyramid looks like. Right, guys? If you're sure about Giza's pyramid, it looks like this, right? Right, guys? Is start from the small point, like we can consider this as the width, right? So like if you want to draw it the width, so it looks like this point, then like this, right? Then like this, then like this, right? And if we see it from the outside, it will look like this. Am I right, guys? That's how the pyramid looks like. Correct, guys? Everyone agrees? That's how the pyramid looks like. And that's what the condition is also, guys. That's what the two conditions they have given, two rules they have given. If we are starting, let's just consider this is the I is equal to 0. This is the first row, or yeah, first row. So they are saying, what is the first rule? First rule is at ith row, total width should be less than width should be less than total width should be less than I plus 1th row. That is the first condition. You can condition as well. If I'm considering this is I is equal to 0, this is I is equal to 1, you can see, right? The width is more for I plus 1. If I consider this as I is equal to 2 and this as I is equal to 3, you can see The first rule is following here or not? Guys, tell me, at any row, you can see the width of it always less than the I plus 1 row. Am I right or not, guys? Right, guys? The first rule, everyone can see that. First rule, can you guys see that? Yes, it's obvious. Yes. Now the second rule is, guys, they are saying the number of width, number of elements at each row, number of element or width, because these elements are width, right? These elements are width. Number of elements slash width at ith row should be less than I plus 1th row. And that's also is obvious, because you can see how will you increase this width. It means definitely there are multiple elements there. How can you increase the width? You can increase the width when you will increase the when you will take the more elements, then only you will increase the width. Am I right, guys? That's how you can see in this example also. The second rule is also following. You can see at I plus 1, there are two elements. You can see these are two elements. But at I plus 2, at the second row, you can see there are three elements. And I is equal to 3, there are more elements. So always, can you guys visualize it that whenever we create the pyramid, always these two rules follows. Like if you just simply consider these as a brick, you can see definitely for considering this particular layer, you definitely need more brick, and the width of this will also be more. Same considering here as well. You can consider this as a brick. Definitely at each level you need more and more brick. Now, guys, can you understood these elements here? Number of elements nothing but width. Yes, number of elements nothing. It's width only. Did you first understand these two rules? These two rules are obvious right here. While we create any pyramid, we always follow these two rules. Am I right, guys? Anyone has any doubt with these two rules? Understood these two rules? Are you guys able to hear me? If yes, why are you guys not responding? What happened? You guys are thinking something? What is it? I just simply told you about the pyramid, right? In the pyramid, how these two rules are applying here. First, tell me, everyone understood these two rules with the pyramid? Now let's second one. Okay, second one. Understand. Second one. See, Arad, second one is saying number of elements slash width slash brick. You can write it as a brick also. Slash brick at ith row, at any row should be lesser than the I plus 1 row. And that's what you can see. In this I is equal to 1 and this is I is equal to 2. So this means it is I plus 1 row. So you can see number of bricks are lesser here compared to I is equal to 2. Got it? Clear? Now let's go into the question. So these number of bricks, so they have given the size of these bricks. They have given the size of these bricks. You can understand. So the size of these bricks are like this: 1, 2, 3, 5, 6, 7. This is the size of brick. And now we need to create a pyramid by following these two rules. By following these two rules. Okay, guys? By following two rules. So at each label, we need to take care of two things here. One is the width, total width at that label, and total number of elements. Am I right, guys? At each label, we need to take care of two things. Total width, it should be greater than the previous one. You can see at each label, the width should be greater than the previous one. You can see I plus 1 should be greater than the I is equal to 0. Same goes for number of bricks. should also be more than the previous element. Okay, so what we'll do, guys, for this question, we'll take 2 pointers here, or we can take 4 pointers actually, 4 pointer. So previous count, previous width, previous count, previous width, current count, current width. Okay, we are going to take the 4 pointers here, 4 variables here, just to track off the previous width, because we need to always check, right? We need to always check, right? Whenever we are at any level. Okay, so what we'll do, guys, for solving this question, we will first by default, we will set our first element as the previous count and previous width. First element, you can see this is the 1. So we'll by default set the previous count as a 1, the first element, and the previous width as a 1. It could be any values, right? Not only 1. But then just I'm setting previous count as a 1 and previous width as a 1. Okay. So so just ignore this variable for right now. Just ignore, we'll use this variable. First understand how will this solution. So see, guys, first brick, which size is 1. Marker has started now creating a problem for us. Now, this is the first brick, guys. So first we'll put first brick here, the size of 1. Okay. Now we can say width is 1 here. And count is also 1 because we are only using 1 width. Now, let's put the second brick at the next level, 2 here. Now, is the width greater than the previous one? So previous width is 1 right here. Previous level, this is I is equal to 0 level. This is I is equal to 1 level. This is next level, right? So first we need to compare the width. Is it greater than the previous one? You guys tell me. Is the width now greater than the previous one? Yes, right? So first condition has been passed. Joseph says no. Why? The width is 2 right here. Width is 2 and earlier width is 1. No, first condition has passed, right? First condition has passed, right? Where the width should be greater. Yes, but second condition is not passing because the count is same. And the second condition was that number of elements or number of brick should be more here. Am I right, guys? The second condition is not passing. First condition is passing, right? Everyone? Only Joseph is answering. What about others? Yeah. So so what we'll do, we'll add the next element here as well. Oh yes, 2 means width. Yes, 2 means width. Yes, these are width, right? These are the brick size. This brick size are width. So now we'll add one more element. Now the total width would be 5 here. So at this level. And now count has become 2. Now condition has been passed. Right, guys? Now I can see the condition has been passed. Both condition has been passed. Both condition has been passed. The total width is 5 and count has become 2. Now we'll go for the next level. Now we'll go for the next level. So now next level, first element, which element is coming? 5. So we'll add the 5 here. This is the next level. Is the width greater than the previous one? You guys tell me, is the width greater than the previous one? Is the width at this level greater than the previous one? This one, 3 to this one at this level. How it is? Total bit. I am talking about total bits, guys. Condition. Why are you not reading the condition? Total bit. At this level, what is the total bit? I have written it also here, right? It's the 5, right? Is it greater now? No, I'm asking about greater. Our condition is very clear. They are not saying about equal, right? It's totally, they are saying greater. Is it greater? At this level, the width, total width here, is it greater than the previous one? No, right? I thought width is, no, that is number of elements. Width is the total width. Total width, or in the question, they have given the, okay, let me cut down the width part. Let's start talking about the brick size. Okay, let's talk about the brick size. Okay. Ah, yeah, that's I think I have made you guys confused. I think I made you guys confused. That's why actually you're not able to understand. Okay. That's fine. That's fine. Let me start from the again. I thought, okay, let me start it from the again. No problem. You see, you guys are not telling right. So that's why actually I was thinking you guys are able to understand. But now you guys are telling me you're not able to understand. So that's why if you will tell it in the starting, and I could make it like earlier, right? You guys will not be confused. So let me now start again. That's fine. That's fine. Okay, guys. So this array element is brick size, whatever you want to say, brick size. You can consider them as the brick size, each element, or brick width, brick width as well. Okay. Now everyone understood first what are the arrays elements are representing? Everyone? That could be brick size as well. That could be brick width as well. Understood now? Now, what is our condition? What is our condition? Our condition is, first condition is at any level, total brick size or total brick width, total brick size, total brick width should be lesser than or should be greater than the previous one. Should be greater than the previous one. Got it, guys? At any level, total brick size, total brick width should be greater than the previous one. That was the first condition. Now tell me, guys, again, right now tell me if you guys are confused here with the first condition. Are you guys able to understand that? The first condition? What about others? Okay. Now what is the second condition? Second condition is at any level, total number of brick. Now they are talking about total number of brick. Total number of brick should be greater than the previous one. Total number of brick should be greater than the previous one. Tell me about second one. Did you guys understood the second condition as well? Everyone. Otherwise, see, when solving, you guys will be confused here. Good? Good? Okay. Now let's try to solve this question. Let's take the first brick. Now I'm taking the first brick. First brick as a default one. So what is the brick size here? 1. So at this level, what would be the total width? What will be the total size or total width? Whatever you want to say. Total size you want to say, that's also fine. Total size. What is total size? It's 1. What is the total number of elements or total count? Total count or number of elements? That's also 1. Am I right, guys? Now you understood the first level. Now let's go for the next level. So, so what is the brick? Next brick is here, which is 2. So I've taken this brick. Here is a 2. So after putting this brick, I need to check these two conditions. Is these two conditions are fulfilling? So first check the first condition. What is the total size right now at this label? At, at this label, what is size right now? What is the total size at that level? It's 2. And our condition says total size at any level should be greater than the previous one. Is it greater than the previous one? Is it greater than the previous one? Yes. Yes, it is. So it is satisfied. So first condition is satisfied. Let's look for the second condition. Let's look for the second condition. What is the second condition? Second condition is saying total number of element at this level should be greater than the previous one. Total number of element at this level should be greater than the previous one. Is it happening? What are the total number of element at this level? What are the total number of element at this level? 1. And in the previous level also it's 1. So that's why this condition is failing. So we are going to add one more brick here. We are going to add one more brick here. So that brick would be this one. This brick. Let's add it. Let's check the condition is matching now or not. Now what would be the total size here? Now what would be after adding 3? What would be the total size? After adding 3, what would be the total size right at this level? It's 5, right? So now it is greater than the previous one. It is greater than the previous one. So now condition is again satisfying. Condition is again satisfying. Now second condition, the total number of count is also 2. That is also satisfying. So now we are okay with this level. Are we okay with this level? Now we'll go for the next level, guys. Now we'll go for the next level. Once the condition is satisfying, we'll go for the next level. So now we'll add it here. Now we'll add 5. Now again tell me, is it after adding 5 at this level, is it matching the first condition? Is it matching the first condition, guys? No, right? Because at the previous level it is 5 and again we are 5. It's not greater. So again we are going to add the next element, which is 6. Which is 6. Now tell me, guys, is it matching the first condition after adding 6? Is it going to match the first condition? First condition. Is it going to match the first condition, guys, after adding 6 there? Yes, because 6 plus 5 is equal to 11 and the previous one total width is 5. So it is matching the condition. But is it the second condition is also matching? No, right? Because second condition says total number of elements and right now total number of elements are same in both levels. So we are going to add the 7 here as well. Right, guys? Now it is matching. Now both conditions are matching or not? Yes. Now both conditions are matching. Now we do not have any other elements here. Now we do not have any other elements. That would be our height of our pyramid. So for this question, height would be 3. 1, 2, and 3. Understood everyone now? The question, every logic, everything. Anyone has any doubt right now? And I think you guys have also thought about, I'm thinking about the logic as well. Everyone understood the question? So now guys, logic is very easy. Logic is very easy. So as I was telling, we will take 4 pointers here, 4 valuable. So because 1 is the default one, the first one will always take it, and we'll take out or height as a out of like we'll take one variable as a height here. Take one variable as a height here, just for tracking our answer, how much level we have find out. We'll take it as a 1 because by default we are putting 1, right? So previous count would be 1, previous would be 1. Right, guys? Previous count would be 1, previous would be 1. Now we'll run our for loop from 1 to n. 1 to n. From this element. from this element till here. Correct, guys? Now we'll first add current width here. Current width would be 2. Correct, right? And current count would be 1. We will compare it with the condition. We'll put the condition, the current count should be greater than previous count. And current width should be greater than the previous width. If this happen, just increase the height plus plus. Just go for the next level. If this happen, you can see if this happen, just increase your height to plus plus. And update the value of previous count and previous width to current count and current width. So update the values also. Because now the updated value of current count, like updated value 5, right? It was 5. So that would be putting in the previous count and previous width. Guys, that was the easy logic. That was the easy logic. Okay, let me show you the code. Very easy code. Let me show you the code as well. Yeah, you can see. First we have sorted our array. Correct? Then what we did, we have taken output. That is our height. The height variable we have taken. So height is equal to 1. The previous width is 0. You can see the previous width, previous count, the first value from the array. Previous count as a 1. Current count 0. Current width as a 0. And then I am running my loop from 1 to n. Adding current I value into current width, increasing the current count. And if the condition is matching, if current width is greater than previous width, current count is greater than previous count, update values of them, update making current count and current width as a 0, output plus plus. And at the end, I'm just simply returning my output. Very easy code. If you just understand the logic, code is easy here. I'm just waiting so you guys can see the code. Code is very easy. Correct, guys? Anyone has any doubt here? Code was very easy. But still, if you guys has anyone and any line, any doubt, let me know. Are we good, guys? Hey, you guys say 2 type of emojis. One like this one, like thinking something. What is it meaning of that? I just want to understand. The thinking meaning means like, what is the meaning of that? Anyone wants to explain it? Your intentions behind it? I always starting out current variable from a new indexes so that we compare with the previous row. Yes, because that would be the first element which we will put, and we have already sorted it out. So that would be the minimum width. You know, in the pyramid, always the top point is the minimum point. We always keep the minimum element at the top. Then we start increasing the bit size in the pyramid, right? You see, pyramid like this. So always on the top, we keep the minimum one. That's why after sorting, we are taking the first element and putting it there. Then we are increasing the pyramid size. Understood, Ekta? Ah, okay. Yeah, it's you, Arad. I got it now. It's you only. Okay, now guys, so that was the question. Can we move into the next one now? Yes? Okay, now let's move into the next one. Now we have one again question, sort array with a equation. You have been given a sorted array of n numbers. Your task is to apply an equation on each element, and after applying, you need to sort it again. So they have given one equation to us. An equation looks like this: ax square plus bx plus c is equal to 0. And they have given the values of a comma b comma c. Every time they will give the value of a comma b comma c. Like in our question, value of a comma b comma c is -1, -2, -3. And they have given you one sorted array, which looks like this: 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 5, 6, 7. Okay, 1, 2, 3, 5, 6, 7. You need to put each value in the equation. You need to put each value in the equations, and you will get the new value. You will get the new value. And after that, after putting each value in the equation, whatever values are getting, you have to sort them again. So let's put the value 1. Let's put the value 1 here in this equation. So a is -1. 1 square plus -2 multiplied by 1 -3. Just add it. Is it minus? All the minus? C is positive. Sorry, guys. C is positive. No, it's not negative. So C is positive. So you can see here -1, -2 plus 3. It would be 0. So for 1, it would come as a 0. Now let's look for 2. What value will 2 get? 1 will be pointing at 2. Let's look for 2 here. So -1, 4 plus -2 multiplied by 2 plus 3. -4 plus 3. It will give us -5. I will stop here. First come into chat. Are you guys able to understand what I'm doing here? First let me, otherwise I will do it and you guys will not understand. Are you guys able to understand what I'm doing here? They have given one equation to us. They have given one equation to us. You need to, and they have given the variables there, a, b, c. So we have the value of a, b, and c. And then they are saying in the point of x, you just put these values one by one and fetch out the values like this, what I'm doing here. 0. When I put 1 here in place of x, I'm getting my equation answer is 0. When I put 2, I get the answer as a -5. I will put 3. I will put 5. I will put 6. Same way, I will put 7. Right? 6 and then 7. So I'm not calculating it, guys, but you can calculate it later. Let me calculate for 3 very quickly. So it would be -9 and -6 plus 3. So this will give us -12. Right? Let's calculate for 5. So -25 -10, right, plus 3. So I think this should give us -32. Let me just correct me, guys, if I'm calculating anywhere wrong values. And then I think for 6 it would be -36 -12 plus 3. So it would be -45. Yeah, -7 -49 -14 plus 3. So I think it will give us plus 3, sorry. It would give us 63 and -60. Correct, guys? So the parallel array will look like this: 0, -5, -12, -32, -45, and -60. The array will look like this, guys. Now you need to sort this array in ascending order, the same order which the input array has been given. So after that, it will look like, which is the smallest one here? -60, -45, then -30, then minus 12, then minus 5, and then 0. That would be our answer, guys. That's what you need to do. That was the question is asking. You just put the values there, and after that, whatever value you are getting it, you have to sort the array at the end and return the sorted array. Everyone got the question now, guys? Anyone here who has not understood the question, quickly tell me. Everyone? Oh, once again. So, Arad, what we are doing in the equations, we are simply putting these values 1, 2, 3, 5, 6, 7. After that, whatever value we got it here, we simply kept it in front of that. You can see in front of that, we have kept it. And after that, the new array which we got, we need to sort that array in the ascending order. And you can see after sorting it out, the array looks like this. And that was our answer. Arad, got it now? We just need to put the values there. We'll get some respective value from the equations. We need to sort them. Understood, everyone? Anyone has any doubt right now? No, I believe no. Okay. So guys, let's observe one thing here. This is parabolic equation. And how the parabolic look like? Look like this. Am I right, guys? That's how the parabolic look like. Ax square plus bx plus c. Yes, everyone agree with that? That's how that look like. And actually not like this, I would say. It looks like this, I think. Oh yeah, no. That's right. That's right. Both are same. Both are same. Both are same. That look like this. Yeah. Okay. So what this is representing, guys? What this is representing? It is representing. 1 minute. Let me delete this one. What this is representing? It is continuously increasing, and after one point, it is decreasing. It is continuously increasing, and after some point it is decreasing. Am I right, guys? Correct, guys? It is continuously increasing, and after that it is continuously decreasing. And what is that point? What is that point from where it has started decreasing? It is the maximum point. It is the maximum point. So before maximum point it is increasing, after maximum point it is decreasing. Can we conclude from that observation or from that equation? Everyone, Likit, Arad, Ekta, Joseph, can we conclude that point? In this parabolic equations, can we conclude this point that after a maximum point, the after a maximum point it is decreasing, before maximum point it is increasing? It is a fact here. It is going to be fact here. 1 minute, guys. 1 minute. Sorry, guys. Like the call was coming again and again. That's why I need to pick it. I was thinking it might be some important task. Yeah, but that's fine. Like maxima and like maxima and minima. I forget about that maxima and minima. But yeah. So my point is here, Joseph. Till this point, I am saying that the values are increasing here, and after this point, you can see values are decreasing here. So with this equation, can we conclude that observation? Ax square plus bxc. That because this is a parabolic equation, right? And the parabolic equation looks like this. In the parabolic equations, there are all are sorted. What does it mean? All are sorted. I am talking about maximum and maximum element, minimum element. What does it mean? How does it related with sorted? Oh yeah, all the elements are sorted. That's right. That's right. All the element in the starting it was sorting. No, no. Do not combine all these things, right? Right now I'm talking about the parabolic equation. Do not attach it. Do not attach it. This thing. First, understand about the parabolic equation. Did you understood that how the parabolic equation looks like? It looks like ax square plus bx plus c, right? In the parabolic equations, it looks like this, right? So in the parabolic equation, there would be one point. That point would be the maximum point. And before this point, you can see all the values will be minimum. Sorry, all the values will be incremented. Then after this max point, all the values will be decrementing. Did you guys understood this point or not? Everyone, is it a fact? It's a fact, right? It's a fact, right? Joseph, did you understood now? Yeah. Everyone understood? Navneet, Hariharan, everyone? Yes. Now let's see, guys. Now let's see in our equation after putting these values, what I'm saying, after a maximum point, you will see always the decreasing point. So in this equation, this is the equation which we got, right? This is the equation which we got after putting the values 1, 2, 3, 5, 6, 7. Right, guys? That was the values which we got, right? So what is the maximum value there? What is the maximum value there in this whole array? What is the maximum value? 0. So you can see that the same observation after 0, everyone is decrementing. Every element here is going to be decremented. You can see here -5, -12, -32, -45, -60, -60. But if we just change this value, if we change, so 0, like instead of 0, let's keep it like some other values. Like I'm just creating some other values. Like if I'm changing the value of a v comma 2, a b c, so right, I'm considering we might be getting something like this as well. um, uh, um, um, 16, 17, 18, 19, 7, 8, sorry, 8, comma 7, comma 6, comma 5. Is this a possible or not? Can this be a possible equation or not of parabolic? Can ax square plus bx plus c can give us these values or not? Can give us this value or not? Because yes, you can see 19 is the max point, and before 19 everything is incremented and sorted, and after that everything is decrementing and also sorted. Same thing, you can see this is the parabolic nature. Now you understood the second array also. That second array could also be possible. Everyone understood? Do not relate it with question. I will come to that part. But first understand the second array could also be the parabolic values. That will also create the parabolic. Can we create the parabolic with this? Yes, we can create 16. Then this is 17. This is 18. This is 19. And then somewhere at 8, like this 8, then 7 or 6, 5. Correct? This will also create the parabolic. Am I right, guys? Joseph, Arad, are you guys, did you guys understood? The second equation will also make that. Yes? Okay. Now why we are talking about all these things? Now let's relate it with our question. Now let's relate it with our question. Because after putting these values in the equation with A, B, and C, we are getting this array. We are getting this array, and we are not sure that this array is going to be sorted every time. You can see here, it is sorted in decremented order. It is sorted in decremented order, but this is not going to happen every time. Even our input array is sorted. Even if our input array is sorted, we are not going to get, after putting the values in the equations, we are not going to get a sorted array. We are going to get some array like this, where there would be one maximum value, and before maximum, all will be sorted in the incremented order, and after maximum, all will be in the decremented order, but it's still sorted. Why? Because they are following the parabolic nature. Now you understood why we are understanding all these things, because this array after calculation is not going to be always sorted. Understood why we are understanding all these things? Because we have to sort it. After putting our sorted arrays values in equation, whatever new array we are going to get, that is not going to be sorted. And the reason for that is the parabolic nature. You can see there would be one max point after finding out, and then there would be some smaller values before than that, then the some values here, then some values here after max point. Now, Joseph, you understood how we are relating it with the question? Arad, because we have to sort our array. We have to sort this array. So for sorting this array, how should we sort it? How should we sort it? Which we are not going to use direct sort method there. We are going to use this property here, and then we are smartly sort it. So which should reduce our time. Understood, guys? We can now smartly sort it our array, right? If somebody wants to sort this array, what they need to do? They need to first find out the mid element. Oh, sorry, max element, not the mid, the max element. This max element could be anywhere. After finding out the max element, we already know that previous to that would always be the smaller element, and after that will also be all the element will be in the sorted array. All the element will be in the sorted array. Previous that and after that, all the element will be in the sorted array. Correct, guys? That's why we were trying to do that's why we understand the parabolic nature, everything. That's why we understood. So now what we'll do, guys, after calculating after doing this calculation part, we will try to find out the maximum element. Now what we'll do, guys, we will put some logic here. We'll put one pointer here, we'll put one pointer at the end. This would be left pointer, this would be right pointer, and we'll take a new array for our answer, or the same array, whatever you want to do. We can take this new array, take the new array for an answer, and we'll track the index of it with the k variable. So right now k is at 0 position. From here, because we are going to put the answer. So now what we'll do, guys, we'll check is our left is smaller than the right? Is our left is smaller than the right? Whoever is smaller than between the 16 and 5, put it at the 0 position. Then decrement your right pointer. Decrement your right pointer to here. Decrement your right pointer to here. Again check. Is your right and left, which one is smaller? 6. Increment your k value as well. We are also incrementing the k value. Okay. So you have taken 3 pointers here. K for tracking your answer, and L and R for tracking your original array. Now your R will be here. And you have to just reach till mid element, till the highest point, not after that. Once you reach the highest point, you will stop it there. Okay. So now again, your right will be at this position. Again, you will check which one is smaller. 7, okay. Then you will check 8, okay. And once now you will reach here. Now you will stop. And your K will be at this position. Right, guys? K will be at this position. Now, after once you reach to mid, you will stop it here, and whatever, like whoever is, you will see continuously. You will check your left and right should always be, left should always be smaller than the mid element or the max element. This is max element, I would say. Your left element, left index should always be smaller than the max element index, and your right index your right index should be, one minute guys, your left index should always be smaller than the max index, yes, and your right index should always be greater than the max index. And if anyone is failing, if any one of is failing, if left index reaches here or right index reaches here, you will stop the loop there. And then after that, you will check that which one has reached. Is the right one has reached or left one has reached? If right one has reached, take all the elements from the left side. So you can see 16, 17, 18, you will directly take it all the elements. And then at the end, you will add the 19 as well. And you can see guys, your array is sorted now. With this approach, you have used the parabolic nature here. Yeah. Then push rest of the element. Yes. And let me now quickly show you in the code as well. Code is also not tough, guys. Same thing, whatever we talked about, we are doing in the same there as well. Equation sorting. That's called as equation sorting. We can't use any sorting mechanism here. Based on the equations only, we are going to sort it. We're not going to use any sorting mechanism. So we need to use the equations. Based on the equations, we need to identify how can we sort it. Okay, so now let me show you first. Okay, so you can see first thing. First thing, I calculated the equation value. You can see A, the value of A, array of I 2 times, plus B, array of I plus C. And I'm keeping the values in the same array of I. Are we good with this line? Line number 13 to 15, guys. Quickly reply me in the chat. We are simply calculating the array's equations values and putting into the same index. Like this one. Like this one, yeah. Like this one, you can say. Yeah, like this one. Or this one. These are also equations values. Good? Okay, now let's move further. Now we need to find out the maximum index or maximum element. Both things. So that's why I iterated into my whole array and find it out the maximum, which you can do here as well. You do not need to write the separate code for this. You can check, because we are already iterating it here. You can already check this here as well. No need to check it again. But here, just for to understand easy, you are checking it again here. Otherwise, you can do the same code here. So now you find out the maximum element and the index as well. Correct? So now you will take two variables. I is the left variable, you can see at the 0th index, and j is the right variable at n-1. Correct? Now we created a new array. We are creating a new array here. And every array index value, we are going to keep it 0. You want to create it, you do not want to create it, that's totally fine. Not a problem if you do not want to create it. And we are going to track the new array index with the value of k. So this is just new array creation, nothing new. This is what just we are creating an array just to keep the values later. But the important thing is here, I, j, k. These are the three variables. K, just for tracking our values here, in which index we need to put the value, and I and j to track our original array. That's what you can see here. Here, left and right, they are going to work at the I and j. Now let me show you where we are doing the comparison. So you can see the comparison. I, the left index, should be less than the maximum index, and j should be greater than the max index. If this is working, if this condition is true, then only go inside this loop, while loop, and then check which one is greater, left one or right one. Which one is greater? If left one is greater, if the right one is greater, you can see array j is right. If right one is greater, then increase, then take the value of I plus plus and put it into the new array. You can see, take the value of I index and put it into the new array, and then increment I index as well, increment the k index as well. Else, take the value of j index, take the value of j and decrement the j index. Whatever we were doing there, right? That's what code is written. And once any of the index I or j or left and right, anyone has crossed the max index, just come out of this while loop, and then check which one has crossed. Is I become greater than index, or j has become lesser than index? In that case, if it's the case of I, add all the remaining element of I in the new array. If it's the j, then add all the elements of j. And at the end, at the last position, add that maximum element which you have fetched it out. And then from the new array, take all the element again into the original array. This line, just they have written some extra code which you can reduce in very nice way. But yeah, the important things are these lines. There you are doing the comparison. This is important. Then this part is important, which you can reduce it. So let's quickly see this code, guys. Anywhere you are stuck, let me know quickly. But yeah, in meanwhile, first let me check in the chat if you guys have any queries. You want me to repeat the logic? Okay. So Joseph, nothing to worry. It's very easy logic, because you have already find it out the max index. That max index is 19. After that, what you did, you have taken two variables here, left and right. Okay, left and right. Now your left index should always be less than max index, and your right index should always be greater than max index. If any one of is not passing the condition, you will come out of the while loop. And if right now you can see left is smaller than max index, yes. Right index is greater than max index, yes. Go inside the loop and check which value is greater or smaller. If 5 is greater, if 5 is smaller, take that value in your new array and decrement the value of r. Decrement the value of r. Now r will be here. Now these two values will be compared. And then you will put it here. And at the end, after doing slowly all the comparison, you will come to this index. Here your right pointer will come. Now your loop will stop, because your right index has become max index, and your condition was your right index should always be greater than max index. But right now it is smaller. Right now it is equal to that. You will break your while loop. And once you break your while loop, you need to add the remaining elements. You will check which index, left index has passed the condition, or right index has, like, which one has like equal to max index. Which one has become? If the right index has become, it means you have to add all the left element. After that, you are simply adding all the left element, 16, 17, 18. And then at the end, you are adding the maximum element. And that's what happening in the code as well. Your left and right are I and j here, I and j. And you have created a new array. For keeping element in new array, you are using k index, the value of flag as a k. You are checking condition here. I should always be less than mid index. J should always be greater than max index, sorry, not mid, max index. And you are here checking whatever element is smaller, take that element, increment that value, put it in the k as well. Again, at the end, once this loop is failing, you are checking which index has been passed. So whatever index has come to the max index, you will take the remaining one. Okay. It was easy, right? You just need to find out the max element, then just traverse each of the elements in the array, keep into the next new array. Not middle, max element. Max element, not the middle element, max element index. All, see, you parabolic, right? All the, yeah, in this case it is middle. Yeah, in this case it is middle, but it will not be middle in every case. You can see in this question here, it was not the middle element, it was the first element only, the max element. You can see in this question, it is the max element. Yeah, for this equation, it is in the middle. Yeah. So you need to find out the max element. Then you need to take the left and right pointers. Then your left pointer should always be less than the max index, and your right index should always be greater than the right index. Then you go into the loop, compare the elements left and right, which one is smaller, keep it in your final array. Start comparing. Then whoever index comes to the come to the max index, stop it there. Check for which index has come to the max index. It means this index has already taken all the values from the right side. I have already taken. If the right index is coming to the max index, it means all the values of right side I already sorted them. It means now the left index values has only left. So we'll now take all the remaining left index value directly into our final array. That's what we are doing. So it's just like we do not need to comparison. We do not need to compare whole array. We are just doing the comparison in half of the time. If it is a linear equation, then it will be last element, right? Yeah, it will linear, then it's n square. The time complexity will be n square. Okay, guys, everyone got it? Anyone has any doubt? Anyone has any doubt? Can we jump into the next question now? Hariharan, Joseph, anyone? Are we good with this question? Yes. So now let's jump into the next question, guys. Oh yeah, no Hariharan today. Yeah. Okay, now let's jump into the next question. Next question is also very easy. Sort an array using a stack. You have to sort an array using a stack. So we have this array 2, 4, 1, 12, 14, 25, 35. So guys, always remember stack has only two operations, pop and push. So we need to use the pop and push to sort this array. Correct? I think that's what the question. No other thing mentioned in the question. They have given you an array. They are saying use stack. You need to sort it. I think you have understood the question, guys. You have to use the stack to sort this array. Understood? So now let's think about. So what we'll do, guys, we'll take first one stack here. We'll push all the element directly here. 2, 4, 1, 12, 14, 25, and we push all the element here. Okay. Now all the element has been pushed here. Okay. Now what we'll do, guys, we'll run one loop. The loop will run from, and loop will run like while loop till this stack become empty. Till this stack become empty. Okay. So now, and we'll take one more stack, guys. Without two stack, we can't solve it. You know that, right? You know that this question. I think in stack, we have already done this question. Without two stack, we can't solve it. Otherwise, we need to go with the recursion way. We need to go with the recursion way, right? But yeah, let's start to solve it. No problem. So see, guys, we have taken one array. So let's pop it. Let's pop this element from here. Let's pop the 35 from here. Right now, our temp stack, we can say this is the temp stack. Temp stack. And this is the main stack. So we have taken the 35 out of it. Now 35 is in the middle. We will check, is temp stack is empty? Yes. So directly push it. Directly push it. 35 is here. Okay. Now let's pop the next element from here. Now let's pop the next element from here, which is 25. Before pushing it here in temp stack, we will check. We will check because we are sorting in the ascending order. Sorting in the ascending order. So if in the temp, if in the stack top we have the greater element, we will not do anything. We will simply push it. If in the temp stack we already have the greater element, we will not do anything here. We will only check there. We will only check the temp stack should be always greater than the current element. If it is not, then we need to do something. We'll do that. But in this case, temp stack is already greater. Correct, guys? Temp stack is already greater. Temp stack is 35, right? So we'll not do anything. We'll simply push it. We'll do check. Temp stack is greater, then fine. Simply push. So 25, we will push it here. Now let's take the next element, which is 14. Now again check, is the temp stack top is greater? Yes, it again greater. So let's push it again. 14. Let's take the next element now, which is 12. Is it great? Is temp stack top is greater? Yes, it is. Simply push it. Push 12 as well. Now let's take the 1 out of it. Is 1 greater? Is the 12 is greater? Temp stack top is greater? Yes. Push it. Okay. Now let's take the next element from here, which is 4. Now tell me, guys, is the temp stack top is greater? Is the temp stack is greater? No. This time it is not greater. What we will do, we will pop the element from here and we will pop till we find out the greater element in stack. We will pop in this stack till we find out the greater element here. And after popping out, we'll push those elements in the main stack. So now let's pop out the 1 from here and push it back into our main stack. So now you can see 1 we have first pushed into the stack. Now we'll again check, is the temp stack is greater? Yes, it is. So this time we will simply push it. So we will only pop 1 element from here and we'll push this 4 here. We'll push this 4 here. Correct? Now let's do the popping again from here. So 1 will come here. Again we'll check, is temp stack top is greater? Yes. Simply push the 1 again. Now let's look for 2. Now let's look for 2. We have popped it out. Again, same check, guys. Is the temp stack is greater than the current? No, it's not. So then simply pop this one and push it back to main stack. And then insert this element into the. Now you can see 4 is greater. Yes, 4 is greater. We push this element back to stack. Here. What is happening? 2. Now let's pop again from the main. Is temp stack is greater? Yes. Push the button. Now you can see main is empty. This stack, just pop all the element from the stack. This will be sorted array. 1, 2, 4, 12, 14, 25, 35. Guys, you got your sorted array with the help of stack. What do you guys say here? Was it difficult? Understood, guys? Yeah, we already did it, yes. Now let me show you the code as well. So this is the array which we are going to sort it. We are passing array and length to the sort array using stack. So first we have inserted all the element in the main stack. You can see input is a stack. So we have inserted all the element in input stack. Then we are passing this input to sort method, which you can see in the top. This is our sort method. You can see this is our main stack, main array, which is going here as the input array. Then we created one more stack, temp stack. Then you can see we are simply checking. This while loop will run till our input length is not equal to 0. This is the first while loop. Then we are checking the temp element, popping it out from the input. Then we are checking if the temp stack length is not equal to 0, and end. Temp stack top should always be temp stack top if it is less than temp. It means the temp stack top is less than temp. It means we need to do the popping. You can see we are doing the popping from the temp stack, and before doing the popping, put the peak element in the input array again. Whatever step we are following, this will continuously run. If this condition is not passing, we'll simply push that temp element which we taken out from the main stack into our temp stack. At the end, we are returning the temp stack, and at the end we are simply popping out all the element from there, adding into our array as a sorted element, and then we can return our array from here. We are not returning it, but yeah, we can return it our array as well from here. Okay, so that's what the code is. I think it's easy. If you guys have understood the logic, this one is not difficult. But yeah, I will wait for you guys to tell me. If you guys stuck somewhere, just let me know in the chat. Let me come back to chat. This is the full code, guys. You can do the same steps in same function as well. That's fine. It has become a little bit more, right? Fine. Now you can see the whole code. Let me increase the size, no problem. Yeah, this one is fine. So we are just simply pushing into the main stack, first all the arrays element. You can consider, see, already it was array, we are still pushing in again into the array because we are considering them as a stack. That's why first we push into the stack, then we take in the temp stack, and then solving it out. Popping and pushing. You can see only the push and pop operations are there, nothing else. Yeah, are we good, guys? 35 and 36 line number. 35 and 36. Yeah, this is the this part, Joseph. Once we have this temp stack array, we need to take our element out of it, right? And put them into the original array. That's what we are doing. We are running our loop, taking the temp stack top, and then assigning into the array I, and then removing that element from the top, popping it out that element. Understood, Joseph? From our sorted stack, we are just taking out the element from there and putting into our array. So yeah, guys, that's all from today. I'm going to push all these changes. All the changes are pushed now. Okay, guys, I know like some questions were interesting today, and some were very easy. And we tried to solve some interesting questions as well. After those heaps and tree questions, this seems too easy. Oh, yes, yes, definitely. All questions was interesting. I think from the next class, which we have on Saturday, there is one interesting question only in that class. All are like here and there. But yeah, there is one interesting question definitely there. I hope guys you have enjoyed the class. Try to solve some interesting questions like the pyramid one. And yeah, please tell what is your question, Arad? Oh yes, yes, Joseph, definitely. Is there any way to change the repo name? Ah yes, why not? We can change it. Let's see. If you are if you are the owner, I think you can change it, right? Let's see. Let's see. Let's see if I'm going here. Here you can see. I can change my repo name in the settings in the general. I can change my repo name. Okay. Just explore it. There are ways. I'm also not sure. A lot of things GitHub provides actually. No problem. A lot of things are good in the UI, right? So I hope you guys have enjoyed it. Let's meet on Saturday morning. And in the meanwhile, I'm continuously saying to you guys, please practice more and more. So you guys should not face any difficulties while you are sitting in any interviews and trying to solve any problems. Yeah. Yeah, please do that. Do not waste your practice. No, no, you don't have 2 days. You have only 1 day, right? It's Friday. On Saturday, I'm again going to meet you. Oh yes, these are all interviews question. Yes, they have covered all the scenarios which sometimes some are the interviews questions, some of the questions are like around the interviews which people ask. They are all creating your minds. They are developing your minds. So now your mind has developed. For making a building, you need a base. You just do some digging and then put some material there. That's what happening here. Now your base is done. Now you should start playing it, start building it. Then you will learn more things there. Yeah. You will see some more things there when you will start solving problems. This has created your base. When you jump into the problems, you will see more things there. Okay, guys. So let's stop the class today here. Let's wrap it here, and let me pack all the things which I had here. So I should not leave anything for tomorrow travel, and then we'll meet on Saturday. Okay? Yeah. Thanks, guys. Bye bye. Good night. Thanks, Ekta. Thanks. Yeah. Bye bye, guys. We'll talk soon.